Activity-based intelligence, or ABI, applies geographic thinking in new ways to help solve today's complex intelligence problems. Implementing ABI involves the convergence of new sources of intelligence information, advancements in technology like big data, the Internet of Things, and a new way of thinking about intelligence production. This new approach creates great opportunities and challenges for organizations that many of you belong to. We believe that GWANT professionals need to lead the way and lend their expertise to realize the promise of ABI. GWANT organizations are postured to take advantage of ABI concepts fairly simply because of the nature of their business and the necessity to geographically visualize and analyze data to glean comprehensive understanding over a particular area in the world. However, the application of these new techniques and new technologies has many potential pitfalls. Let's explore how we can apply these lessons we know from implementing ABI to overcome some of those pitfalls. First, let's talk about why you should be interested in ABI at all. The U.S. Undersecretary of Defense for Intelligence has found value in this approach and defines ABI as a method of intelligence where analysis and subsequent collection is focused on the activity and transactions associated with an entity, a population, or an area of interest. This definition is the tip of the iceberg to what ABI can do for the intelligence community. While this definition can help us understand what ABI is, it is probably quite useful to understand why we need ABI and how it fits into the current landscape of intelligence. The modern intelligence profession really began with a focus on human intelligence and managing of a single threat. Over time, new technical capabilities were developed to collect intelligence information. Organizations were created based on intelligence disciplines to wring out as much intel as possible from each piece of data collected. Robust rules were developed for understanding the signatures of our enemies based on fixed locations and known targets. After 9/11, the game was changed. The enemy no longer had fixed signatures or known target locations. This is where we began to break down some of our intelligence stovepipes and form multidiscipline intelligence teams. This is also when many of the techniques for ABI were beginning to be developed. Today, we are now seeing the threat become increasingly complex, with new threats and new technologies being applied, leading us to aspire for a true integrated intelligence environment that provides comprehensive understanding. Many groups have been performing all-source or integrated intelligence for years. This new age of intelligence required these smaller operations to be taken to a larger scale and to a new workforce. In addition to the increasing need for understanding of a complex threat environment, we also have new technology developments. There's an explosion of new sources of information, drones, consumer devices, social media, and real-time reporting. This new data creates demand for new applications, the app revolution, providing people access to information with the ability to analyze it and visualize it like never before. These advancements all ride on new technology trends with great increase in computing power and storage. Similar to many technology trends, every user wants a personalized view of information with the data, like you may see on your common social media applications. Fact, we can create data environments for managing and storing these vast new collections of data and make it available to anyone in the organization, on any device, at any time, and in a manner that is meaningful for them. This convergence of these new technologies and increased intelligence capability has led to the creation of new intelligence approaches like that of ABI. These new methods do not replace any of the time-tested analytic processes already developed. Instead, it formalizes a methodology and shifts focus from intelligence reporting to the discovery of the unknown. Activity-based intelligence is a set of spatiotemporal analytic methods to discover correlations, resolve unknowns, understand networks, develop knowledge, drive collection, all using a diverse data sets to understand the environment. And basically to understand the environment and not just a specific location or a specific facility. Many traditional intelligence methods were focused on analyzing and exploiting information based on known targets and locations, or known behaviors and signatures of adversaries. ABI is really focused on tackling the unknown unknowns. Discovery is fundamentally a data-driven process. Traditional techniques focused on known locations or known signatures. Instead, ABI is focused on finding the unknown unknown. The output of ABI is a resolved entity, a defined pattern of life, or an understanding of an unknown behavior or phenomena. Think of the logic that may lead you to understand the activities prior to an attack. You'll have advanced recon, increased training, frequent meetings, traveling outside of normal areas, etc. Putting this activity into context is the purpose of ABI. ABI fits into the traditional intelligence cycle. While most of traditional intelligence was focused on tasking and collection of critical assets, ABI is focused on processing and exploitation of the increasing wealth of data we have at our disposal to actually glean understanding. There is a never-ending debate. Who exactly invented ABI? Who owns ABI? Is ABI itself even a new concept? Everyone who's looked at ABI seems to agree that the techniques used in ABI are valuable and relevant to today's complex world. As you think about implementing ABI in your organization, I hope you find it useful to learn from those that went before you. The early practitioners of ABI didn't know they were inventing a new method as they developed it. In fact, they were just explorers trying to reach a new promised land and setting the path for those that followed behind them. As they explored, they made many mistakes, which you can learn from. As you will soon see, the application of geographic information is a fundamental underpinning of ABI. As geo professionals, you can be the guides for your organization as they proceed down this perilous path. Help them take the right steps, avoid missteps, and take advantage of technology. Let's start with the first problem of ABI. Spatially correlating information. We need to have a single method to manage and correlate multi-intelligence information. The early explorers tried many different techniques. They created large object relational databases with complex ontologies. They created data lakes of unstructured information. They fully text indexed their information and made it easy to search and find the data. The problem with all these techniques is that all of the information required analysts to sift through the data and perform cognitive correlation of data. What was needed was a common framework that could be applied to all of the data to actually glean more understanding from it, while decreasing the analytic timelines and manpower to arrive this needed information. The early explorers discovered something many of us have known all along. The only common organizing framework we can apply to all information is space and time. All activity occurs at a place and at a time. We can use geography as an organizing principle to help us correlate information and enable us to discover key events, trends, and patterns in our data. By managing our information in a spatial temporal construct, we can apply robust analytic tools to the data. We can use time-tested techniques to curate and capture data. The early practitioners of this simply started by adding X, Y, and T, or time, to all of their data. This let them put their dots on a map, but more importantly, visualize the spatial importance or relevance of data over geography, over times of interest. This simple technique allowed them to visualize and ask complex questions of their data. As organizations became more advanced, they realized that there was more they could do with this information. They could represent information using complex geographic relationships. They could add context to their information by geo-enriching the information. This allowed them to leverage the wealth of geographic knowledge they already had in their organization, and it made their intelligence information richer and more valuable. This took them beyond visualizing and into a complete understanding of the context for the data to help them answer questions about a particular geography or a target. This approach establishes the first pillar of ABI, georeference to discover, instead of exploiting, then georeferencing. The second problem of ABI was the challenge of moving from a world of single source exploitation to a true integrated multi-environment. In the early days of ABI, analysts would exploit their individual intelligence sources before correlating them with other data. This resulted in many significant activities being overlooked because the separate intel datasets were not interesting in isolation. The fact is, the more you know about a particular area, the better your analytic output will be. Let's face it, most analysts begin with their analysis with reviewing the last report of a facility or of order of battle. They start from what they already know. Early attempts to correct this fell short. Early applications brought together views of the raw intelligence data into a single view, which did allow analysts to integrate the data. However, they were unable to perform more robust analytics because the integration only occurred at the application level. For most apps, this meant that they could only see the data but not analyze or understand it. If you need to perform real-time or predictive analytics, you would need to build that into every application, instead of leveraging existing architectures. Obviously, many companies could get rich off of this technique, but it did not scale well for the organization. What our early explorers figured out is that they can create a solid logical architecture with separation between data, visualization, analysis, and applications. They leveraged open standards to integrate many systems instead of application-level integration. Using this technique, they could apply real-time and big data analytics to perform intelligence analysis at machine speed. This lets analysis analyze the data at the point of entry. This key concept allows real analysis to take advantage of the data, but it also ensures there's an analytic value to the data you store for forensic analysis. The inverse isn't true. You can't just store data separately and then later hope that forensic analysis will bring it together. This establishes the second pillar of ABI, integration before exploitation. The third problem of ABI was the challenge of moving to a world of scarce single-source intelligence to one of plentiful data from multiple sources. Early so-called ABI systems were actually purpose-built to specifically exploit some new intelligence sources like wide area motion imagery, or WAMI, and other technical collection. This worked well until the problem set shifted and we had to work in denied areas where the sources of information were different. The problem is that the different data requires different tools and applications in order to work properly, in order to visualize, synthesize, and analyze the data. The same exact application can't be used for WAMI and Twitter data, for example. One needs a complex video player with capabilities, and the other needs rich media interaction. To combat this problem, ABI teams would have embedded developers. They could customize and build the applications needed based on the individual data sources. This was great for the teams, but it did not scale. Application maintenance became problematic, and building a staff of capable developers can be nearly impossible. What our explorers figured out is that we need to prize all data regardless of source. This means establishing a standard practice for integrating all data into analytic processes. They applied the best practices in their architecture. They had logical separation of data and applications. This allowed them to leverage standard commercial applications to exploit much of their data. Professionals had their tool sets, their desktop GIS, their statistical packages, and advanced visualization tools, which could be leveraged to exploit the data. Application frameworks would be used by advanced staff to capture and share focused tradecraft across the organization. These frameworks do not require developers, and they allow for quick creation of focused apps on a common foundation, which could be used quickly and then discarded. Enabling the exploitation of all types of data regardless of source. This established the third pillar of ABI, data neutrality. Sometimes the answer arrives before you ask the question. This is probably the most vexing problem in ABI. Oftentimes, by the time you know which question you are asking, it is too late to begin collecting and tasking the process. What you need is to have already been collecting the information in the first place to answer the question. Our early practitioners tried to solve this problem with technology alone. They created big data archives and dumped all sorts of information into it, with the assumption that they could make sense of the data later. The problem with this approach is that the information still needed to be cleaned and normalized and prepared for analysis. There's a lot of noise in the data that needed to be sorted out, and the more unfiltered data collected, the more noise there was. This is where our early explorers defined our next pillar, sequence neutrality. You need to collect data without a question defined and store the data where it can be retrieved and analyzed easily. This changes how you think about tasking and collection. This pillar introduces new challenges, however. How do we logically manage and store information and make it available for analysts to discover and use? How do we condition the data to make it possible to have key data already correlated and information connections already defined? This is where we need to leave the realm of activity-based intelligence and examine the larger intelligence enterprise. Our intelligence enterprise should be the core enabler to a smarter community. It functions for a larger purpose than just supporting activity-based intelligence. We are managing our strategic and current intelligence. We're developing our basic intelligence profiles of organizations, equipment, and individuals. This foundation intelligence information has to be made available as data and analytic services so it can be combined and leveraged in an ABI context. For example, the data we are collecting about facilities can be used to help us identify individuals connected to a facility. Connect that with points of interest data, and you can rapidly build a picture of an individual's pattern of life. Foundation intelligence provides situational awareness, monitoring, and reporting information. It is the organizing model for our known information. ABI consumes information from our foundational systems, and it contributes data and develops new information. You can think of this in terms of object-based production, or OBP. OBP provides a set of known entities and relationships. ABI is used to identify new entities and to extend networks. This foundation intelligence helps us correlate entities. Foundation GeoInt provides context about a location and about its human geography and surrounding areas, combining these to create new understandings. From our early explorers, we've learned that there are four essential pillars of ABI: georeference to discover, integration before exploitation, data neutrality, and sequence neutrality. For these to have any relevance, they need to be connected to our intelligence enterprise, where they consume data and analytic processes and contribute new information. ABI adds the method of discovery intelligence to our intelligence disciplines. We think ABI is a major advancement in intelligence technique, which has enterprise GIS at its heart. So as you return to your organizations, perhaps you should work with your counterparts who are already implementing ABI and see if these principles and these new techniques would be useful to you. Remember, in this complex world, it is not enough to apply the tried and tested method of intelligence. We must expand our toolset with a focus on discovering the unknown unknowns and contributing new kinds of intelligence analysis. ABI, with its foundation in spatial thinking, can help address this challenge. So now that we've looked at the fundamentals of activity-based intelligence, let's see how we would actually use activity-based intelligence in the context of a real intelligence problem. So we're actually going to start with, we're going to take a look at the current situation in Libya and some of the intelligence questions that arise out of Libya. So we worked with our partners at IHS Janes to look at their analysis for Libya, and we put that information into the story map to help us walk through and understand the current situation in Libya. So, since the fall of Colonel Gaddafi, Libya is now a divided country. There's a power struggle between competing factions that's kind of escalated into a near civil war, and that's really split the country into multiple factions. So here we see this control map that shows the different areas controlled by the different factions. The two factions that we're really going to be paying attention to is in the west, the Presidential Council, and this is kind of the area they control, and then in the east, the Libyan National Army. So you can see that this is a fairly complex sets of territory that they're controlling, slightly unusual control maps, and slightly interesting dynamics that are going on in the country. So let's explore those just a little bit more. So neither group totally controls the forces. They have armed opposition in their countries. Over the past 5 years, there's been a lot of armed conflict in a variety of areas. Most of it makes sense if you look in the north, of course, where the majority of the population in Libya is. You would, of course, expect to see a lot of these attacks and incidents. In those areas, these are all kinds of different attacks. Some of the attacks can be explained by the strong presence of the Islamic State in Libya until recently. And some of it can be, of course, just explained by regular conflicts in some of these control areas, and then just the general, of course, lawlessness in the country. But primarily what's happened now is the Islamic State has mostly been defeated in the north, and they've moved down to the south. And now we're trying to look at is, what's going to happen next. So to understand what's going to happen next, we need to understand a little bit more about why the control map looks the way that it does. What we're really looking at is this need to control different territory in these areas. So this is the area that the Islamic State used to own, and now that buffer is removed, and the conflict's going to has the potential to grow now that there's no longer that buffer in this area that was being caused by the Islamic State. What we really see in this area, though, is really that the control map, when you actually lay it on top of the infrastructure, it starts to make a lot more sense. You can actually see the different production facilities, oil and gas production fields, industrial plants that they're taking control over. So you can kind of see the control map actually follows a lot of the key industrial complexes and areas that need to be controlled to extract energy resources from the area. So for example, this is one of the main oil basins, the Sirte oil basin over here. Kind of shows us where one of the key oil corridors. There's another corridor, of course, here in the west where you can kind of see the main pipelines that's bring oil and other energy from other areas in the region. We also have some offshore oil as well. And so basically, you can see that the territory control is about controlling access to those resources. And there are some areas that are still kind of uncontrolled or unmanaged by either of these two groups that also are oil producing and have some infrastructure as well. In general, these attacks that are happening, they're trying not to target the infrastructure. They're actually trying to keep it running in order to keep the energy flowing smoothly and also to take over the energy resources as they happen. There is occasionally, offenses that happen. Occasionally some damage occurs to the facilities, but in general, they're attempting to control those without doing that. The other thing that you definitely can see a pattern of is the targeting of these major roads. So controlling the roads is a key part of controlling the terrain, controlling the supply along the roads, the movement of people and personnel and goods, and that helps keep control over these actual areas. One thing that they actually do target historically has actually been airfields, and here we actually can see a three-dimensional view of the airfields, and actually this is captured by Vricon, so they can rapidly produce kind of 3D models, and actually in this case they actually produced the model from digital globe imagery that was collected after an attack, and we can actually kind of see a little bit of before and after the attack in the area. We can actually see some of the damaged aircraft inside the 3D view and get a better sense of kind of the damage that's happened. But this is the kind of attacks that have been happening and the challenges it can create, obviously, for infrastructure in the area. So now we're going to move from the kind of historical background to the thinking from the analysts at IHS Janes about what's the possible scenarios for the future. And we're really going to focus on two scenarios, whether there's going to be a renewed East-West civil war in central Libya and what we think might happen with the Islamic State. And both of these scenarios may unfold here in the future and in the next couple of years. So the primary scenario that we definitely have been looking at, and as you see in the control map, it kind of makes sense, this idea of a renewed East-West civil war. So with the removal of that Islamic State buffer in that kind of central area, which has been the focus for many for the recent history, these two major groups, we expect them to have conflicts with each other and potentially renew that civil war, and basically to regain territory and control of energy resources. In the analysis of those areas, they identified some key flashpoints. So the flashpoints, along the road intersections, for example, to control those road intersections, possibly airstrikes on ships along the coast and targeting some of the cities up there along the coast as well. The primary thing I think we're going to focus on as we start to look at ABI is actually going to be these road intersections. The other reality that could unfold and that may happen is this Islamic State. They've relocated essentially into the tribal regions in Libya. They've relocated there and they're basically establishing themselves in that region. And that could lead to some new flashpoints with them basically doing kind of asymmetrical warfare, attacks, kidnappings, assassinations, etc., to continue to destabilize the organizations there. So those are the two broad scenarios. They'll set context that we want to now start to think about how would we use activity-based intelligence inside of this context. So you can remember from our activity-based intelligence talk, we're going to use these 4 pillars of ABI: georeference to discover, data neutrality, integration before exploitation, and sequence neutrality, along with the key enabling technology of geo-enrichment, real-time analytics, big data analytics, some application frameworks, and then of course connecting back into information coming from our broader intelligence enterprise, which brings the data together into a variety of applications and provides access to it in an open way. So when we think about activity-based intelligence, we think about how it fits into the larger intelligence picture. So when you look at an intelligence, you take a problem and you're going to decompose it into different questions you want answered. So the broader question might be, what are the intentions of the Presidential Council with the removal of the Islamic State? Well, activity-based intelligence won't answer that question. Right? It's a very high-level modeling question. But as we start to dissect into sub-problems, we can ask the question about, is the council going to try to retake that Sirte oil basin, which was in the east? And then how would we answer that question with ABI? Well, we'd want to look at things like activities that would indicate, are they going to do it? When are they going to do it? How would they do it? And to do that, we want to look at the pattern of life and behaviors associated with key Presidential Council forces. So inside of activity-based intelligence, there's this common pattern for analytics, and it's pretty simple, but very powerful, actually. It's this concept of who, where, who, or where, who, where. It's basically, what do you know to start from? In our case, we know locations, those flashpoints that we talked about earlier. So we're going to start with a where, and then using our ABI methods, we're going to try to find a who, and then we're going to follow that person and figure out where they go, and that's going to establish more wheres. And then following that pattern, we're going to find more who's. So basically finding these coincidental relationships and activities of entities in order to understand a larger pattern and to develop a network and possibly answer these intelligence questions. So this will be a pretty simple example, but the concept applies even if you're dealing with a large scale set of operational actors in a large network. So to begin with, we want to start with the real-time analysis. So we start at the data ingest point. As we mentioned earlier, the real key to activity-based intelligence is going to be analyzing the data at the point of ingest as your first phase operation. That's going to help us condition the data, prepare it for analysis, but also detect patterns in real time so we can actually understand what's happening as it unfolds. So here we're going to take a look at a simple form of activity-based intelligence analysis that I refer to as movement analytics. So movement analytics is about taking data from a variety of different sources. So data, for example, like sense locations. So these might be locations like data coming from license plate trackers, SIGINT hits. They might be from GPS devices, transponders, etc. Then we bring that data together, and we also use other location sources like volunteer location. So this might be somebody unintentionally giving you their voluntary location, or it could be the deliberate voluntary location. Things like a social media check-in, uploading of a geotagged photo, use of credit cards or other things, other financial transactions, things that would basically be a person self-identifying their location. And the final category is observed location. Observed locations are when somebody else observes somebody at a location. So that might be a human report. That might be from information where you've combined a couple intelligence sources, maybe using imagery or other remote sensing, full motion video, drones, other things like that, where you're observing their location remotely. All this information gets fused together into what we call stay locations, and then these get geo-enriched and tagged based on locations we're monitoring. So areas that we're monitoring for suspicious activity, or areas we're monitoring because we want to be alerted when something happens. And that's essentially going to drive our initial analysis to help us get started with that where to who kind of problem. The way that we do that is we actually implement and we use real-time modeling. So we build real-time models to take that same logic we just talked about to tag people with the locations they operate in and to track their sequence of activity. And we build those and we put those into our geo event processor, and that's how we process the data in real time to create a real-time picture of situational awareness. So what that's going to do is that's going to... All right, so now what we're going to do is we're going to actually take a look at that real-time information that we've been collecting. So we've been monitoring, those flashpoint areas on the map, and now we're going to take a look at what information we can glean from that. So what we've done is we set up a geofence around these intersections, a fairly large geofence, and we just wanted to detect any activity in that area. And we basically just have a couple of points to show the location of an individual. This is our halata. So what we want to do is we want to see if that's an individual we should be concerned about or wanting to look into. So what we'll do is we'll kind of go back out to the whole area of interest, and we'll take a look at just his pattern of life. So I'm going to use kind of a predefined filter, and we'll see, okay, he's got a pattern of activity that we've captured of his activity in a few different locations that we've been monitoring. And what we notice about it right away is that these locations are all pretty much up here in the Northwest. And what's interesting about that is those locations in the Northwest are in one group's control area, and then he's down here at this right intersection, another group's control area, which is by itself probably a little bit suspicious, and that might be enough to trigger us to say this is somebody we should look into. So starting with that kind of simple assumption, just looking at it in a very simple way. Now what we want to start to do is we want to start to look at how he connects to other intelligence information. So what we want to do is just kind of move forward in this, and we want to make sure that we're integrating all of our reporting information. So we mentioned this before, that one of the key concepts in activity-based intelligence is that concept of georeference to discover. So we want to make sure we're georeferencing all of our data. So for example, we may be getting in suspicious reporting that has human reporting. So in this case, we're identifying a specific shipping vessel. And we might want to use that reporting to then try to figure out if there's something else tied to this guy. So we noticed that he's got some activity up here in this port areas that we were monitoring. So he's been operating at this port, the same port that was identified in that human report that we're looking at earlier. So those locations possibly tied in time and location to that shipping report. So now we want to think about how we would actually analyze to understand what's happening. And in order to do that, we're going to need to combine a couple of techniques. So we have the real-time analytics that's been happening. We've been capturing all of our data, georeferencing it, doing that alerting and tagging. We've also been capturing other sources of information and putting that into our spatial temporal data environment. And now what we want to be able to do is go back and do some kinds of other periodic analysis, dig back into the big data, query the data, analyze it in order to understand it. So for example, in this case, we have our shipping data, and we might want to actually look at that shipping data to see if there's anything about that vessel that would be suspicious. So here we have our shipping data. What we're actually looking at right now is all of the shipping data in this area, and it's automatically being kind of aggregated into the cells for us to look at. And we can look at this data in a couple different ways. Right now we're looking at it by count. We can also look at it by speed. And what happens is, see, it's being dynamically aggregated based on the average minimum speed. So that gives us ideas of kind of normal minimum speeds in areas. We can kind of see where people are moving, what we expect their normal speeds to be, places where they move really slow, places they typically move faster than others, places where they're typically stopped. So that gives us a sense. We can use that as a way to get a sense of the movement of vessels in the area and get kind of understand the overall pattern. And this is all coming dynamically from the shipping data. So if we zoom in to one of these areas, we can kind of see that actually once we get down in it, we'll see the actual individual vessels. And so this is just the raw track data coming from any of the vessels in the area. So this is our big data archive of our shipping data. Now, how would we use that to understand any of the patterns in the data? So we had the HUMIT report and identified a specific ship for us. So we can actually query our big data archive. In this case, the ship was identified by name and MIMSI number, but we'll just use the name. And so we can actually execute a query, and we can kind of see where has that shipping vessel been in general. So we can see the individual tracks. We can see what his speed has been over time, where he's operating. Is that typical areas for ships to operate? And basically the question does what shipping vessels typically do. It operates around the port. It spends a lot of time out here fishing, spending some time at sea, and it comes back. But the key thing is it doesn't go anywhere else. It's not going to other ports or other locations. It's just going to and from out to sea and back to the port. So in that case, we basically can kind of discount the idea that it's any kind of suspicious vessel connected to our actor. And that's common. You're going to need to do that kind of analysis to figure out where we're connected. And so in this case, the two scenarios we're probably trying to play out is our suspicious individual connected to the Islamic State, which might have been something if he's using the ship to move him around, if he's been moving around a lot of different control areas, or is he connected to the military? So now we'll kind of move forward, and now we want to actually start to see if we can extend that who, where, who pattern. So we want to go from a person, we go to the locations where they are active, and then we want to look at other locations. And inside of activity-based intelligence, there's this concept of location types. And what we're really looking for are the discrete locations. It's a place where our individual's going that people wouldn't typically go to unless they're related to them or connected to them in some way. So we're just going to look for coincidence in space and time at locations that are discrete. So if he's at a shopping mall, for example, lots of people go there for lots of good reasons. That's not a discrete location, so it's not as strong of an indicator. But if he's going to known meeting locations or a house or some kind of other private location, that might be an indicator. So go back to our dashboard, and we'll go ahead and look at this area where he spends most of his time up in the city. And we can see his pattern of activity in these different areas, the locations he's been visiting, the locations others have been visiting, a specific restaurant with some of our other individuals who have been operating in that area. And what we'll find, if we look at these specific locations, is certain people that we might want to look at as well. So we can query just for those people. And we can see where they spend all their time, right? So we can see that, okay, there's this other guy, and he spends a lot of his time over at this military base. So we can kind of see them there, right? And so, we want to see where they've been, where their activity's been. They've operated in a few different areas, and that, so now we know they're tied to the military. Now we might be able to learn a little bit more about them. So that can lead us to some new locations. So again, contending that circle, who, where, then who, and this investigative pattern just continues. So kind of following this pattern to its logical conclusion, we now want to know a little bit more about this military unit. Well, we actually just happen to have, and this is actually a true story, we actually did have a video of an actual unit training with artillery in this area. So we could use that video, we could capture structured observations from that video, and that would be used to identify that, in fact, those military people that we're tracking were tied to this artillery unit. So at this point, this is a bit of a leap to jump to this conclusion, but we can see how we might reach a conclusion that guy was probably tied to this military group. We'd probably want to spend more time developing evidence, but based on what we've seen so far, he's probably tied to that artillery unit, and we think very likely then that he was actually in those locations we were monitoring, doing advanced reconnaissance and targeting for that. And so that's why he wasn't going to the military base, but he was operating in the same areas as them and communicating with them. So from that, we would now do, our traditional terrain analysis. We'd look at their location. We'd look for routes that they might take to to get to that intersection or to get to places they could target the intersection. We use all the kind of vehicle and data from Jane's, and we use our predictive analytics tools to do analysis to identify where they would travel, where they might go. This would let us then do for future planning to do monitoring to determine if they're actually going to do an attack or identify what their likely targets might be. So in summary, we brought together different data in real time. We brought together data in our big data store. We analyzed all that data together. We viewed it in our dashboard application to understand the patterns of life and activity. We use focused applications to query our big data store and to do additional querying and analysis on our data. And based on that, we're able to follow that pattern of who, where, who, and answer that intelligence question, basically that we believe that they are going to attack, they're planning artillery strikes, they're going to take over those road intersections. That helps us answer that bigger intelligence question. And that helps explain a little bit of context on how ABI fits into the intelligence picture, but also how we can use our kind of geospatial workflows and technologies to help us and answer an actual ABI question. A key reference I used while I was working on this presentation is an excellent book called Activity-Based Intelligence, Principles and Applications by Patrick Biltkin and Stephen Ryan. If you want more information on activity-based intelligence or how a location platform can help you enable your intelligence enterprise, please visit esri.com/intelligence. Thank you for your time.